All right, so I think I'm recording. We have been looking at quadratic equations and different techniques of solving quadratic equations. And here they're asking us to solve this, but to do it by completing the square. So we can't factor and we can't use the quadratic formula. We have to follow the directions. All right, so in number 10, the first thing I look to see is it in standard form? Is there any greatest common factor? And there's not. And I also need that leading coefficient to be a 1. So I have 1x squared minus 14x. I'm going to move the constant term to the other side of the equation. I'm going to subtract 40 from both sides of the equation. And now I'm going to figure out what constant term I really needed. It wasn't 40. That was take half of negative 14, square it. That's what I need that constant to be. So half of negative 14 is negative 7, but negative 7 squared is 49. So if this number were 49, I'll be able to factor this left-hand side. Now, since this is an equation, I have to balance it. Since I just added 49 to the left-hand side, I need to add 49 to the right-hand side. So now what that does for me is I'm able to factor this trinomial into a perfect square. Half of negative 14, negative 7, quantity squared, and 49 minus 40 is 9. So now I can take the square root of both sides, the principal square root, and that's the absolute value of x minus 7, and that's equal to 3. Well, this splits into two equations, that this is equal to negative 3, or that this is equal to positive 3. 7 minus 3 is 4. 7 plus 3 is 10. Here's our two solutions to this equation, and we did it by a process that they call completing the square. If you had factored it, you'd get the same answer. If you'd used the quadratic formula, you'd get the same answer. I know the original problem would have factored because my solutions there were rational numbers, not irrational numbers. All right. Let's come over and do the second one. I have x squared, and I have a 1x squared. I need that. Minus 6x. I need to take half of negative 6, the linear term, and square it. Half of negative 6 is negative 3, but negative 3 squared is 9. So I'm going to add 9 to the left-hand side, which means that I'm going to have to balance the equation. I'm going to have to also add 9 to the right-hand side. By doing that, by having this constant term be a 9, this left-hand side factors to x minus 3 quantity squared. How did I get the negative 3? Well, it was half of negative 6. 15 plus 9 is 24. I need to take the square root of each side, because step by step I'm trying to get the x by itself. Square root of a variable here results in the absolute value of x minus 3, and 24, the biggest perfect square that divides 24 is 4, and the square root of 4 is 2, and I can't simplify the square root of 6. So this splits into two equations. X minus 3 is equal to negative 2 square root of 6, or x minus 3 is equal to positive 2 square root of 6. We have 3 minus 2 radical 6 is one solution, and 3 plus 2 radical 6 is the other solution. because these solutions contain irrational numbers, I know that factoring would not have worked with this original expression, but the quadratic formula would have provided this same solution. In fact, how you get the quadratic, you use completing the square to derive the quadratic formula. All right, so let's try to shrink this up to give me some room to do this last one. Huh. It's strange how you have to move the mouse to. All right. So let's take a look at this last one. First thing I notice about these numbers, 2, 8, and 10, is they're all even numbers. So I'm going to divide everybody by 2. 1x squared plus 4x is equal to 5. And that's fantastic that it worked out this way, because I need a 1 as a coefficient in front of that x squared. We'll see in other more complicated problems how we deal with it if you didn't have a greatest common factor, but here we did. Half of 4 is 2, and 2 squared is 4. So I'm going to add 4 there so that I can factor the left-hand side into a perfect square. To balance the equation, I'm going to add 4 to the right-hand side. So since half of 4 is 2, this factors to x plus 2 quantity squared is equal to 9. If I take the square root of both sides, it will help me to get the x by itself. At least it helps me to get rid of the radical 2, or excuse me, the exponent 2. This splits into 2 equations. Most students skip over that step of absolute value, but then that also means that most students, I think, believe that the principal square root of 9 is -3 or +3. The reason this negative comes into play is because the absolute value is because we took the square root of a variable. So anyway, -5 and +1 turn out to be our 2 solutions, but the technique we used to get these solutions was a process that's called completing the square. Hope that helps, and I will talk to you later. Bye.